G'day everyone, welcome to Lubrication Explained. In this video, we're going to talk about the fundamentals of base oil oxidation. We're going to do it in 3 different steps, from beginner through intermediate and advanced. Hopefully it's helpful in framing the discussion. So the first way that we can think of base oil oxidation is cooking. Very simple analogy. And I could probably end the video here because this is really all you need to know. Fundamentally, oil which cooks over a pan and oil which oxidizes in, let's say, a hydraulic pack, it's undergoing the same process. So it's heat and oxygen breaking down the organic components of the oil. So in cooking, it goes through the same process, but a little bit quicker. You know, you might be using a vegetable oil or a fat. They will break down in service, and as it heats up, it'll start to form black deposits and sludge. And this is exactly the same as the kind of process that we see in our application. So at a very basic level, so this is level 1, you can think of base oil oxidation as the cooking of the lubricant. Easy enough. Alright, step 2, let's get into the intermediate process, which is understanding a little bit of the chemistry. And here, as you probably know from high school, oxidation is loss of electrons and reduction is gain of electrons. You may be familiar with the mnemonic oil rig. So oxidation is loss, reduction is gain. This is one of the chemical understandings of redox reactions. But to simplify it down, we can also think of, let's say, oxidation is the loss of hydrogen and reduction is gain of hydrogen. Or oxidation is gain of oxygen and reduction is loss of oxygen. So this will simplify it down a little bit and help us understand the reaction a little more. The most basic of all these oxidation reactions is really the combustion of methane. So methane being the most simple of all the hydrocarbons, CH4, it combines with oxygen and you get carbon dioxide and water. So the end product of pretty much all hydrocarbon oxidation is carbon dioxide. And this is actually one of the reasons why, if you look at the atmosphere, the Earth's atmosphere, you don't really see many hydrocarbons present aside from carbon dioxide. And that's because any long-chain hydrocarbons, whether they're, let's say, propane or butane, if any of those are released into the atmosphere, they do eventually oxidize and break down into carbon dioxide. And so that's why carbon dioxide is the predominant carbon-based gas that we have in our atmosphere. So let's think of that reaction. So we have a methane molecule and 2 oxygens, and it would combine into carbon dioxide and water. So what's happened to the carbon? Well, the carbon has gained 2 oxygens, or alternatively, you can think of it as it lost 4 hydrogens. So as per our previous definitions, it was oxidized because it gained oxygens or it lost hydrogens. There is also, going back to the electron model, so oxidation is loss of electrons. So the carbons, in a sense, did lose them because the way that carbon bonds with hydrogen is different to the way that carbon bonds with oxygen. But again, to simplify our understanding, we can think of it as the gain of oxygen and the loss of hydrogen. Now this is the combustion reaction. So methane undergoing what we might call fast oxidation and turning into carbon dioxide and water. However, in most oxidation reactions, there are kind of intermediate products, and this is what happens when you have a slow oxidation process like you do in base oils. So let's start with methane and let's start to oxidize it. So we can introduce 1 oxygen and make methanol. We can then lose a couple of hydrogens to make formaldehyde. we can then add another oxygen to make formate, and then we lose 2 hydrogens to make carbon dioxide. So as we went further down that chain reaction, we were getting closer to carbon dioxide, and the carbon molecule was getting further and further oxidized as we added oxygens in and removed hydrogens. So that's the important thing. So hopefully that gives you an idea for all those intermediate products. So when a base oil oxidizes, we get, acidic components forming in the lubricant, and that's all those intermediate products as hydrocarbons start to make their way and break down into carbon dioxide. All right, so that was the intermediate explanation. Let's talk about the advanced explanation, which is the auto-oxidation cycle. So let's start with what we might call an alkyl group. So we're going to represent R here, in common terminology, can be any kind of any kind of hydrocarbon, and the H is just the last hydrogen that's attached to that. So this could be methane, ethane, ethylene, decane, octane, whatever. Now what happens is that we can kind of pull off a hydrogen through, it could be irradiated with UV radiation, it could be heat, which breaks that hydrogen to carbon bond, it could be physical shearing even. So somehow we break the bond between the alkyl group and the hydrogen. So the hydrogen goes away, and what we form is a radical. Now in radical chemistry, basically this R dot represents a molecule that has an unpaired valence electron. So what that means is it's highly reactive. It's looking for another chemical to react with. And a very reactive chemical, which is present everywhere in our atmosphere, is oxygen. Now oxygen is really, 2 oxygen atoms. So the oxygen molecule is 2 oxygen atoms, and this radical is going to react with that oxygen, and it's going to form another radical compound. Now that radical compound is also very highly reactive. So as we go further along, it can react with another alkyl, so another base oil molecule, and it will actually react with that to pull apart the hydrogen, and we end up with both a radical and a hydroperoxide. So this is the first cycle. Now I'm going to describe the second cycle, and then we'll put them both together. So this hydroperoxide easily decomposes into what's called an alkoxy radical and a hydroxy radical, which can then further react with other alkyl groups to form both a radical and an alcohol, as well as water and another radical. Okay, so water being H2O. Alright, so now let's put that all together and see what it looks like, so that how this auto-oxidation cycle kind of feeds on itself. Alright, so we're going to start with breaking that alkyl group. It goes away, we form a radical, that radical reacts with oxygen, it forms another radical, which then reacts with an alkyl group, forms a hydroperoxide and a radical, and then we get both loops going at the same time. And what you can see is once both loops have been completed, we now have 3 radicals and a hydroperoxide with no further input aside from breaking that original alkyl group into a radical. And so this is what's called the auto-oxidation cycle. And when we put it all together, this cycle is really important to understand, because this is how oxidation runaway happens in a base oil. It really feeds on itself. And when we get to talking about oxidation inhibitors, so antioxidant additives, those work by breaking one of these two cycles, so inhibiting one of those reactions and stopping the chain reaction. So that's why this is quite an important one to understand, and this diagram is one that I will return to in future videos. So I hope that's been helpful. It might have been a little bit confusing, but remember, whenever you're trying to explain it to yourself, think of the cooking of oil. That is far and away the simplest explanation. So I hope this has been helpful. As usual, if you have any questions or comments, please leave them in the comment section below. This has been Lubrication Explained.